Inequalities. When I say the topic of inequalities, copy the title. So we just saw equations and systems of equations. So an equation is basically comparing two expressions by an equal sign because they have the same value. And inequality is comparing two expressions, but not across an equal sign. We're going to find a relationship. So what are the possible relationships? Well, if one quantity is greater than the other one, we use this symbol over here, and this reads as x is greater than y. Then we have this other symbol over here, which reads as x is less than y, which means the value of x is less than the value of y. Then we have this symbol over here, which reads as x is greater than or equal to y, which means here x can also be equal to y. And in this case, we have this reads as x is less than or equal to y, which means that x can be y, but can also take a value that is less than y. In the case of inequality, remember that the answer is a range of possible values. It's not one specific value. Okay, pause the video, copy all of this, and we are going to move on. How do we solve inequalities again? The answer gives you a range, doesn't give you a specific value. So when I put, so if I x plus 1 is less than 5, so x is less than 4, which means x can be any value, negative, positive, whatever value before the number 4. So x can be 3.99, x can be negative 100, any value before 4. When we have greater than or less than, it means it's not inclusive, so it doesn't take the value. So in this case, in this example, we have x is more than 6, is not inclusive, which means x cannot be 6. X can be 6.1, 6.2, 6.00001, but not 6. We have the equal to, so greater than or less than or equal to, it means it's inclusive. So when I have this over here, it means that x can take the value of 6. So x can be 6, 6.1, etc. Pause the video right here, copy everything you have to copy, adding and subtracting across an inequality. So when we have an inequality, we can add or subtract across the inequality sign. So when we're dealing across in a linear inequality, so we have a is less than b, so I can just add c to both sides. So a plus c is less than b plus c, nothing changes. And when I have a linear system of inequalities, I can also add or subtract across the system. So in this case, a plus x will be less than b plus x will be less than c plus x. Nothing changes. I can also pass to the other side. If you think this is a way of passing to the other side, when I have a minus b is less than c, I can pass the b to the other side, and this leads as a is less than b plus c. Again, adding and subtracting, I can totally pass to the other side. I can also add two inequalities across the same symbols. When I have inequality 1, a is less than b, and c is less than c, both are less than symbols, so I can add vertically. So a plus c is less than b plus d. This only works for adding. This does not work for subtracting. Okay, pause the video, copy everything, and we are going to move on. Okay, what about multiplying and dividing? Well, here we have two cases, positive and negatives. When we are dealing with positive numbers, we can just multiply or divide by the same positive number on both sides. So, for example, if I have a over x is less than b, I can pass the x, I can multiply times x, like times x and times x on both sides. And if x is positive, both just I keep passing to the other side, and the inequality remains. So for example, if I have 3x is less than 6, right, I can pass the 3 dividing, so x is less than 2. And in the case of multiplying, if I have x divided by 3 is less than 2, I can pass the 3 multiplying, and x is less than 6, right? If what I'm passing to the other side is positive, I doesn't really matter. I can multiply and I can divide as long as it's positive. What happens when it's negative, though? When it's negative, okay, I can also multiply, pass to the other side, but the symbol is going to change. So when I have a over x is less than b, I can pass my x to the other side. So a will be in one side and xb will be on the other side, but I'm switching the sign. Instead of saying less than b, I'm switching to more than xb. And the same thing happens here. So when I have ax is less than bx, I can simplify the x, but if the x is negative, I'm going to switch the symbol. I'm going to switch the relationship. So in this case, when I have 3 or negative 3x is less than 6, I can't pass my 3 dividing, x is going to be, not equal. So I have 6 over negative 3x, but I'm going to switch the relationship. Now instead of less than, it's going to be more than, so x is going to be more, sorry, and it's not 3x, it's just 3. It's going to be more than negative 2. Okay? Pause the video right now, copy everything you see here, and we are going to move on. Okay, what about ratios and products with inequalities? So this is just a little extra information that you need to solve certain questions, or it's going to be easier for you to solve certain questions. So when the ratio or the product of two quantities is greater than 0, so for example, when you have x over y is more than 0, it means that they both have the same sign, which means x and y are positive, or x and y are both negative. So the ratio, so when we divide them, we can get a positive number. And when the product is positive, so again, either x and y are positive, or x and y are negative. Because when we multiply two positive numbers, they give us a positive number. When we multiply two negative numbers, they give us a negative number. In the case of the ratio or the product being negative, less than 0, then if we have x over y is less than 0, it means that one has to be positive and the other negative. So either x is positive and y is negative, or x is negative and y is positive. If you can see this with examples, so for example, if I have 3 over 7, yes, 3 over 7 is positive, perfect. And negative 3 over negative 7 is also positive. But in this case, if I want a negative, I cannot put 3 over 7. I need negative 3 over positive 7 or positive 3 over negative 7. The same thing happens with the product. Pause the video right here, copy everything, and we're going to move on. Reciprocals. Now, the reciprocal of a number is basically dividing dividing 1 by the number. So the reciprocal of 3 is going to be 1 over 3. So in the reciprocal of an inequality, the inequality sign is going to change. So for example, if x is less than 3, then the reciprocal 1 over x is going to be more than the reciprocal of 3. Okay, in a way you can think of this as I'm passing the x to the other side. If you can think of this as, oh, because I'm actually passing the x to this side and the 3 to this side, so I have 1 over 3 is less than 1 over x. So this kind of makes sense. And you can apply this to a system of inequalities as long as they all have the same sign. If this is positive, 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 or negative, 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 1 over a is going to be more than 1 over b, is going to be more than 1 over c. Pause the video right now, copy everything, and we are going to move on. Okay, how do we deal with quadratics? Remember that an inequality doesn't give you a specific answer, it gives you a range of answers. So in the case of a quadratic, it's pretty much the same. I'm going to solve the equation, right? Either factorizing or using the general formula, but we have to remember that we're finding a range. So if I find the roots, right, and my quadratic equation was more than 0, then I'm choosing these solutions, these ranges of solutions of everything up to that first root and everything after the second root. And if my quadratic equation is less than 0, I'm going to still find the two roots, and then my answer is going to be the range between the two roots. Pause the video right now, copy everything you see, and we are going to move on. Okay, how do we graph inequalities? Because when we graph an equation, basically a linear equation is just a line, right? But how do we graph inequalities? Because the inequality is not really a line. The inequality is a region, it's a range. So what we're going to do is, let's say I have my inequality. Let's say I have 3x plus 7 is less than 10. So what's going to happen is I'm going to use the equation of the line, which means I'm going to put this in terms of the equations. I'm going to put 3x plus 7 is equal to 10. Then I'm going to solve the equation, like putting everything to 0. So 3x minus 3 is going to be equal to 0. I'm going to draw the line. I'm going to draw my line. And I'm going to shadow above if I'm doing greater than or equal. And I'm shadow below if I have less than or equal to. Pause the video. Copy everything. We're going to explain. Okay. How does this look? It looks like this. I have my plane. I have my line. The line will correspond to the equation. So this line over here corresponds to the equation. The equation meaning we're comparing them using the equal sign. And then everything that is above that line, right? In this case, everything that is shadow corresponds to the equation being greater than. So y greater than mx plus b. And everything below that line, in this case, what is not shadow, will correspond to y is less than mx plus b. Pause the video right now, copy everything you see, and we are going to move on. Now, how do we graph a system of equations? Well, basically, we kind of do the process that we just learned, but we do it for the two lines. So we have equation 1, we shadow above or shadow below. Equation 2, we shadow above, shadow below. And the region that we have in common is basically the region that is the solution. So the solution is the region in common. We shadow the region for each, we find where they intersect, and that's going to be our answer. Pause the video right now, copy everything, and we're going to do an exercise. We're going to do an example over here. Now, I have my two corresponding equations. So this line 1 is going to be negative. So line 1 will correspond to this over here, and line 2 correspond to this over here. Now, I'm going to tell you the first one. So the region that is marked by the red dot corresponds to which system of inequalities. I'm going to solve this one, and then I want you to solve the other ones, okay? Now, the region in red is above line 1, but you see it's above line 1, and it's also above line 2, which means in both cases we're doing a greater than, right? So my region in red is going to be y is greater than negative 1 half x plus 4, and y is greater than 1/5 x minus 2. This is my system for the region in red. So what I want you to do now is I want you to pause the video and find the system for the green dot, the blue dot, and the yellow dot. Copy them on your notebook, and we're going to check. Okay, so the green dot is above line 2 because this is line 2, but it's below line 1. So the green dot is going to be below line 1, so less than negative 1 half x plus 4, but above line 2, so it's going to be more than 1/5 x minus 2. Now, the blue dot is below line 1 because this is line 1, and it is also below line 2. So the blue dot is going to be less than negative 1 half x plus 4, and it's also going to be less than 1/5 x minus, this is a minus 2 because it's below both. And finally, the yellow region, this yellow region here is above line 1 but below line 2. So it's above line 1, right? So more than negative 1 half x plus 4, but below line 2. So less than 1/5 x minus 2. Okay, pause the video right here, copy if you have to copy, and we are going to move on. Okay, here's the first example of an inequality. I want you to pause the video, solve this, write down the answer, and we're going to check. Okay, so here, which of the following integers is a solution to this inequality here? We're going to solve this inequality, right? So we're going to see this is about x, so we're going to find the x, and I want to move x to the sign which is going to give me a positive result. So I'm going to move the negative 7x to the left. So I have negative 3x plus 7x minus 7 is less than or equal to negative 27. So I solve this. This gives me 4x. So 4x minus 7 is less than or equal to negative 27. Now I'm going to move the 7 to the other side, the negative 7. So I have 4x is less than or equal negative 27 plus 7. So I have 4x is less than or equal to negative 27 plus 7, gives me negative 20. I'm going to pass the 4 dividing, so x is less than or equal to negative 5. Now, which values are less than or equal to negative 5? In this case, you may think is 5 and 6 and so on, but it's actually negative 5, negative 6, and so on to the left, which means when we have my number line, these are my 0, these are my positive numbers, these are my negative numbers, negative 5 is over here, and my negative numbers grow to the right, all my numbers grow to the right and diminish to the left, which means negative 6 is actually less than negative 5, right? And this is very important because in the case of 5 and 6, then yes, 5 is less than 6, but negative 6 is less than negative 5. Now, since I don't have a negative 5 in my alternatives and all of these answers, all of these alternatives are to the right of negative 5, my answer is going to be negative 6, letter A. Copy this if you have to copy. We are going to move on. Okay, I'm going to stop here, pause the video, solve this question, write down the answer. We are going to check. Okay, this is a word problem. So ecologists have determined that number of frogs y, number of frogs is y, must be greater than or equal, okay, greater than or equal to 3 times the number of snakes. So greater than or equal to 3x. I have my first equation, inequality, sorry. Let's look at the second one. In addition, the number of frogs, which was y, and the number of snakes, which was x, must sum, so sum to at least 400. When I say at least 400, means 400 is the least, right? So I want 400 is the minimum. So I want more than 400. But since it says at least 400 means it can be 400. So it's going to be more than or equal to 400, which is my second inequality. Which alternative has that inequality? Letter C. Y is greater than or equal to 3x and y plus x is greater than or equal to 400. Pause the video right now, copy this, and this was a word problem. So how do we solve word problems with inequalities? Well, this is the way to read the word problems. So when they say at least is exemplified or used with this symbol over here, the greater than or equal. Because if I have at least 2, if x is at least 2, it means like 2 is a value that x can take, and then any value above above 2. When they say at most or up to, if they say x is at most 2, means that 2 is the top value, the maximum value, and then any value below that. Pause the video, copy everything, and we're going to see some examples. So I want to pause the video right here, solve this question over here, write down the answer, and we're going to check. Okay, so what is the greatest integral value of x such that 1 minus 2x is at least 6? Again, when we see at least, means that at least 6 means that 6 is the minimum possible value, which means 6 is the minimum, and then we want anything above that value. So at least 6 is greater than or equal to 6. So we have 1 minus 2x is greater than or equal to 6. So I'm going to solve for x. So I have 1 is more than or equal to 6 plus 2x because I want my x to be positive. So I'm going to move my 6 to the other side. 1 minus 6 is more than or equal to 2x. So I have negative 5 is more than or equal to 2x. So negative 2.5 is more than or equal to x. Since they are asking us for an integer value, we don't want just any value. We want the integer value. We're looking for any integer value that is less than negative 2.5. And the closest will be negative 3. Negative 3 will be the answer is the greatest integer value that is less than negative 2.5. Remember, this is negative 2.5 and this is negative 3. Negative 3 is less than negative 2.5. Pause the video, copy, and we're going to move on. Okay, I want you to pause the video over here, copy or solve this question over here, and we are find the answer, copy the answer on your notebook, and we are going to check. Okay, so here is like a big word problem, but we can still solve it. This reads, so this, okay, is the cost of manufacturing n items. N is the number of items. So a profit is made when the total revenue from selling, so the profit from what we sell, the price for the items, is greater than the total cost of manufacturing the same, which is this. This is the cost of manufacturing an item. So if each item can be sold for $14, which of the following inequalities gives all the possibilities of n? Now, n is the number of items, which means the value that I get by selling them is the number of items times the price of items. So 14n. And for us to find a profit, this has to be greater, okay, than the cost, which is this equation over here. So 14n has to be greater than 8n plus 522, right? So what do? I'm going to solve for n. So 14n minus 8n is greater than 522. So I'm going to subtract for n. So I have, 14n minus 8n, I have 6n is more than 522. So I have n is more than 522 divided by 6, which is 87, which is the answer. Okay, pause the video, copy if you have to copy. We are going to move on to the application for digital SAT. Okay, so here's the first question for digital SAT. I want you to pause the video, solve this question, write down the answer, and we're going to check. Okay, so this question reads like this. The total cost in dollars to rent a server consists of, so we have 25 fee service and $10 per hour, which means in 1 hour, $10, in 2 hours, 2 times 20, etc. Right? So we have 25 plus 10 hours. But a person rents a server for T hours. Okay, they're telling me that there are T hours, so instead of H, I'm going to put T. So 25 plus 10 T. And intends to spend a maximum of 75. If it's a maximum of 75, means 75 is the maximum. So we want values that are below. So it's going to be less than or equal to $75, which is alternative D. Pause the video, copy if you have to copy. We're going to do the next one. So pause the video over here, solve this question over here, and we're going to see. Okay, the point x comma 53 is a solution to the system of inequalities. So all I have to do is plug in this value over here. If I plug it in the first inequalities, yes, of course 53 is more than 14. That doesn't really help me that much. I'm going to plug it in the second inequality. So when I see the x is x and y is going to be 53, this reads as x equals x and y equals 53. So these are the values I'm going to take. So I'm going to plug it in the second inequality. 4x plus 53 is less than 18. Again, I'm looking for x. So I have 4x is less than 18 minus 53. So again, I'm just going to keep solving. So 4x is going to be less than, and I'm solving this. This is equal to 35. And I have x is less than, if you use your calculator and you divide 35 by divided by 4, it's going to give you 8.75. Okay. Now, my advice is you don't really need to do it. Now, since the digital city allows for a calculator, you can get the answer, which is perfectly fine. This is negative 33, sorry, this is negative. So we have negative 8.75. So we're looking for a number that is less than negative 8.75. And the alternative will be letter A, which is negative 9. Negative 9 is less than negative 8.75. Now, the thing I was telling you is that, let's say I'm here. I'm in this point over here. So 4x is less than negative 35, right? So I know that when I pass this 4 to the other side, since 8 times 4 is 32, this is going to be negative 8 point something. And I don't really care about that, what exactly it is, because I'm looking for integer numbers, because all my alternatives are integer numbers. So all I have to do is look for the closest to negative 8, so a number that is less than negative 8. And the only answer that I find is a negative 9. Okay, now, is there another way of solving this question? You can plug in the alternatives. Okay, this is a method that we're going to learn at the very end, but you can just always do it by plugging the alternatives. Okay, so if you want to learn more or practice more about inequalities, you can use these chapters in the Panda book, in the Barron's book. You can also remember you can use Khan Academy or official practice tests. And we're going to move on to the next topic in the theory.